All right, so in this video, we're going to continue with our 2 by 2 systems of linear equations, and we're going to look at our last technique for solving these, which is called elimination. So in the previous video, we looked at solving with graphing, solving with substitution, and now this is the last way that we can solve these. So any of the techniques technically will work on any of the problems. It just is sort of certain problems lend themselves better to one method versus the other. So it's good to have different tools that you can use when you're solving these systems. So let's go ahead and let's take a look at this example 3 here. And I'm going to, as usual, label these as equations 1 and 2. Okay, now the thing with elimination, the idea is going to be that we're going to add our equations together so that we're able to cancel out one of the variables. Now, when you look at these equations, you'll notice that equation 1 has a negative 3y and equation 2 has a positive 3y. This is what's going to tell us that this system is going to be good for elimination. So the reason here is that if we were to add these two equations together, the negative 3y and the positive 3y, they're opposites of each other, so they're going to cancel each other out. So that's exactly what we're going to do here. I'm going to go ahead and add these two equations together. So, and just add right down the columns, okay? So we have a 2x plus a 5x. That's going to be a 7x. Like I said here, the negative 3y and the positive 3y, those just cancel. So those are gone. And then 5 plus 9 gives us a 14. Okay, so 7x is equal to 14. Right, from here, it's easy to just solve for x. So divide by 7, and we end up with x is equal to 2. Okay. From there, we do just like we did with our substitution. Once you find the first variable, you're just going to back substitute in order to find the second variable. Now, the nice thing about systems, remember, is you're finding the solution that solves both systems simultaneously. So it does not matter which equation you plug this x equals 2 back into. You could plug it into equation 1, you could plug it into equation 2, and you will get the same answer no matter what. Okay, so I'm going to go ahead and just plug it into equation 1. It's just an arbitrary choice. And I'm just plugging 2 in for my x. Okay. All right, so we have 4 minus 3y is equal to 5. Subtract the 4 over. So negative 3y is equal to 1. Divide by the negative 3. And we end up with y is equal to negative 1/3. So the last step is just to write this as an ordered pair. So our solution is going to be 2, negative 1/3. Okay. All right, so this is the idea with elimination, okay? Adding your equations together in order to eliminate one of the variables, solve for the other, and then back substitute to find the remaining variable, okay? Now in this situation, it happened to work out really nicely that that we already had our variables that were opposites of each other. We had the negative 3 on top, we had the positive 3 on the bottom. But in a lot of instances, it won't be quite as clean to begin with, and we'll have to do a little bit of work in order to make these equations cancel. Let's go ahead and look at another example where we have to work a little bit harder to get there. I'm going to again call this equation 1 and 2. Okay, so this time you'll notice right off the bat we don't have anything that's opposites. We have a negative 3 and a positive 1 for our x's. We have a positive 6 and a negative 2 for our y's. So it doesn't quite work out as cleanly as it did on the last one. So this time what we're going to have to do is sort of force our variables to cancel out. So the way that we do this is we can multiply either one or both of our equations through by some constant, okay? So I'm going to go ahead and look at this and say, okay, I'm just going to focus on my y's, okay, just to have something to look at. So on top, we have a positive 6. Now, if I want to use elimination, that would mean that I want a negative 6 on the bottom so that these two variables would cancel out. Well, that's pretty easy to accomplish. If we just multiply this through by a positive 3, we would have those opposite y values and we'd be able to cancel it. So let's go ahead and just rewrite this. Okay, so the top equation I'm going to leave as is, but the bottom equation I'm going to multiply by a 3. Okay. All right, and then just rewriting this a little bit simplified, we'd have a negative 3x plus 6y is equal to 5, and then multiplying that whole second equation through by 3, you get 3x minus 6y is equal to 6. So make sure you remember to multiply all the terms in the equation by that 3. Okay, so now we can add our equations up. So if we do so, a couple things are going to happen here. Notice we have a negative 3x and a positive 3x. So if we add those, they cancel. We also have a positive 6y and a negative 6y. Again, if you add those, they cancel. So there's nothing left on the left-hand side, which means we're left with a 0 over there. And then on the right-hand side, 5 plus 6 gives us 11. Okay. All right, so all of our variables canceled out, and we're left with this statement 0 equals 11. But that's not a true statement. Okay, no matter what x and y are, 0 can never equal 11. So because this is a false statement, we say that there is no solution. Okay, so if all of your variables cancel out and you're left with two different numbers on each side of your equation, then there's going to be no solution. Okay, this is in contrast to one that we looked at in the previous video. Remember this example up here where all of our variables canceled, but we had the same number on both sides of the equation. Okay, if it's the same number on both sides, then we said we had infinitely many solutions. But if it's a different number on both sides of the equation, then it's no solution. Okay, and of course, if your variables don't cancel, then you'll just get an ordered pair. Okay, let's look at one more example. So again, I'm just going to label these equations 1 and 2. Okay, now just like the last one, we don't have anything that's going to cancel right off the bat. We have a negative 2 and a positive 3 for our x's, positive 7 and a negative 5 for our y's. So nothing is going to cancel right off the bat. So again, we're going to have to multiply in order to get these variables to cancel out nicely. Okay, now on this one, it might be easiest if we actually multiply both equations through by something instead of just one, so that we can avoid having to use any fractions. So I'm going to focus on my x's, and I want to try and get these variables to cancel. So the easiest way to do that would be multiply the top by 3 and to multiply the bottom by 2. They already have opposite signs, which is good, that's what we want. We just have to get them to be the same number. So again, I said I'm going to multiply the top equation by 3, and I'm going to multiply the bottom equation by 2. Okay. All right, now if we do that, let's go ahead and just rewrite this. We would get a negative 6x plus 21y is equal to negative 45. And then multiplying the bottom equation through by 2, we get 6x minus 10y is equal to 12. All right, now we're in a position to eliminate. So if we add these equations up, our x's, we have a negative 6x and a positive 6x. So those cancel. That's good. That's what we wanted. And then we have a 21y minus 10y. So that's going to be an 11y. And then negative 45 plus 12 will give us a negative 33. All right, and then just solving for y, divide by 11 on both sides. we end up with y is equal to -3. All right, so we found one of our variables. Now we just need to back substitute. And remember, it doesn't matter which equation we plug this back into. It can be equation 1 or equation 2. We will get the same answer no matter what. So I like equation 2 a little better. Not quite as big of numbers to work with. So I'm going to go ahead and plug this into equation 2. So substituting -3 in for y. So 3x minus 5 times -3 is equal to 6. So that'd be 3x plus 15 is equal to 6. Subtract the 15 over. So 3x equals -9. And then divide by 3. And we get x equals -3. All right, so putting all this together, we have the point -3, -3. All right, guys, so that is it for elimination. So there is a lab to go through on this stuff, and then we're also going to go through some application problems with these 2x2 systems as well. So keep watching the videos, try your homework, go over the lab, and just email me if you have any questions.